what happens is when you bring Q naught in the presence of Q, okay, when you bring Q naught in the presence of Q, it is going to experience a certain force. And we know Coulomb's force, Coulomb's law, which says F is equal to A, okay, Q, in this case, this is the Q, and then we have Q naught divided by R square. Okay. Electric field intensity, E, okay, will be the force experienced by this charge Q naught, okay, this charge test upon Q naught. Okay, who is experiencing the force? Q naught is experiencing. So force upon Q naught. Okay, so if we know what F is, okay, considering F is equal to, okay, E is equal to F, and F was what? K Q1 Q naught by R square, okay, and upon Q naught. So this Q naught gets cancelled. So your electric field intensity is basically KQ by R square. Okay, see what is the electric field intensity on a charge Q with respect to a uniformly charged ring. Okay, pay attention, everyone. It's very simple, and those who know very good. Okay. Let's consider this to be a ring. Okay, please bear with me. The board is actually very small, and so what happens is it is zoomed in, so I have very less amount of space. So I'll be continuously erasing the equations. So if you have to write down, please write down with me, and it will be helpful. Okay, let's consider this to be a uniformly charged ring. Please mind my drawings. And let's consider there's a point over here, P. Okay, let's consider this to be having a point P over here. And P is at a certain distance from the ring, considering this as R. Okay, this is R. So, also let's consider this to be having some radius, capital R. Okay. Consider this to be having a radius, capital R. Mind my handwriting, it's not very good. Okay. So, I want to tell you a small trick. When you are doing a sum where you are finding the electric field intensity due to a ring, it is always good to take a small element. And why, I will tell you. Why can't we do it without derivation and integration? The thing is, if you take a small element dq, let's consider this. There's a small element over here, okay, and it is dq. dq. This dq is the same thing which we did earlier. That is the point charge, the force of 2 point charge, the electric field intensity into charges. This small amount of dq is going to produce some amount of force. Okay, some amount of force on this point P. Now for example, take this P as a point where you have brought a test charge. Doesn't matter because anyways, electric field intensity is independent of the test charge. Okay, so there is this dq. Okay, it is going to produce a certain amount of force on this point, considering that to be a test charge in this angle, in this along this one, and this will be dE. Why is it dE? Because you are taking dq. Okay, if you are taking a small amount of charge and you're finding out the electric field intensity due to the small amount of charge, it would be a small amount of electric field intensity also. I hope you're understanding this. It's very simple. Okay. Now we know Pythagoras theorem. This you know the distance between these 2 points is basically what? It is root of capital R square plus small r square. Okay. This capital R and the small r. Okay. So that is r square plus r square. I hope you know that. Okay. Now let's go to the equation part. Okay. Once you get this small drawing, you should be able to draw these small things. Then you can directly jump into the equation without actually worrying about how complicated it is going to be. It's going to be very easy. Trust me. So you take, that E is equal to. Okay, write it down with me if you don't know about it. you know about it, good. It's kind of a revision. So k cube, okay, by r square. And so what, this is the general form. Now let's look, if you're considering dq and de, it will be differentiation of this electric field intensity, which will be equal to dq in this dq. Why? Because k is constant and r is constant. Anyways, you're going to differentiate the variables. Okay. So dE is equal to k into dq upon r square. But what is r? What is r square? Okay. What is this r square? R square is simply the distance between these two charges, which you get by Pythagoras theorem, that is k, dq upon, okay, r square. R square mein, if you put this, you will simply get r square plus small r square. Okay. I hope this is very understandable. Okay. So now this is dE. It is dE, but it is the electric field intensity at a certain angle from the x-axis. What we want is the electric field intensity at the axis of this ring. Okay, we want electric field intensity at this point. Okay, we want. So this is dE cos theta. Okay, why? This is making an angle theta, and the same thing here will be an angle theta. Some are asking why. If you take a straight line, you bisect it like this, and the angle over here will be equal to the angle over here. Okay, so these two angles are basically equal. That is a nice standard subject. Nothing to be ashamed of. If you don't know, you just need to work hard. Okay, so D. So now, since I said we found DE over here at this point, we need to find at DE cos theta. This is DE. You take it at a certain angle. It's DE cos theta. So you just multiply cos theta on both sides. So what will you get? You get, just dropping it off. You can write it all along with me. So you get DE cos theta equal to K dq upon r square. Okay. Sorry. Wait. This r is basically capital R square plus r square into cos theta. Okay. Now look at this. Here, this theta, okay, cos theta, can be written in some other form. So what is cos theta? We have studied it in 10th, adjacent upon hypotenuse raised to 3 by 2. Okay. So now we have written cos theta in terms of r and capital R. Okay. Now what you need to do is you need to integrate. Why integrate? Because right now everything in this equation, the constant k, this k is constant, r is constant, small r is constant, this r is constant. What is not constant is dq. What is dq? It's a small amount of charge at this ring. We have taken a small element, so we need to integrate that. Okay, I'm going to rub it off. So this, okay, we need to basically simply integrate dE, and integration of that simply be dq. Now considering the fact that k, r, small r are constants, okay, we will take them out. Another r. So we will take all of this out. So what you get? Simply get uh, r square plus r square raised to 3 by 2 integration of dq. Integration of dq. And the integration of this small element. Okay. See, this is a uniformly charged ring. So the entire charge on this ring is a capital Q. It's a capital Q. Okay. So integration, that means simply the summation of all the points of dq. You take a dq here and you keep adding dq. That is the meaning of integration. Suppose. Still confused. dq, dq, dq. So what basically you will end up getting? You get Q, capital Q. Basically, it is the entire amount of charge, dq. Okay, so integration of dq will simply be equal to Q. Simply be equal to Q. So this is the electric field intensity. This is the electric field intensity, okay, at the x-axis. The x-axis. Okay. So electric field intensity due to a uniformly charged ring